One of the most excitingly different wildflower encounters at this time of the year, late spring coming into early summer, is finding Toothwort, which stands out among the leaf litter and fallen branches in its woodland habitat, not by virtue of the bright colours that characterise so many spring flowers, but because of its ghostly pallor. And this is due to the fact that Toothwort is entirely devoid of chlorophyll, because it's a parasite, feeding on the roots of hazel usually, from which it draws its nourishment through special suckers that are developed on the underground stems, the rhizomes, through which it obtains whatever nutriment it needs from its host. And the flowering stalks are the only part of the plant that appear above ground. The inflorescence is a one-sided hairy raceme. A raceme is like a spike, but the individual flowers have short stalks. The absence of colour takes nothing away from the flowers' complexity, though. They are every bit as beautifully adapted to visits of the bumblebees that pollinate them as are other bumblebee specialists in the snapdragon family to which it belongs. The suckers through which the toothwort absorbs its nutrients from its hazel host die back in the autumn, but we'll come back to that later on. Around here there are 4 groups of flowers. There's this one. This is the largest of them. There's a smaller group just over there, and a third much smaller group just behind me over here. But there's also a 4th group over here. This 4th group is out of sight, hidden under this tree, almost invisible where no other plant can grow. But of course Toothwort doesn't need the light because it doesn't possess chlorophyll. There are 4 hairy sepals united to form a notched tube and the 2-lipped zygomorphic corolla, very typical of its snapdragon family. There are 2 pairs of anthers, one pair in front of the other, the anthers of each pair locked together so exactly by stiff filaments not a single grain of flowery pollen can fall out, unless they are subjected to the shock provided by the probing proboscis of a visiting bumblebee. There is a long style with a prominent 2-lobed stigma that peeps out at the entrance as the flower opens, while the anthers below remain still closed. Bumblebees suck the nectar secreted by a succulent cushion below the ovary, having first brushed against the stigma, transferring any foreign pollen they are carrying. The nectar entrance is so narrowly and exactly defined that the insect cannot comfortably deviate a hair's breadth from it. I mentioned earlier that the suckers, by means of which the toothwort absorbs its nutrients from its host hazel plant, die back in the autumn. But that doesn't mean that it stops feeding. But it does undergo the most extraordinary change in diet. And to understand that, we need to look at the rhizomes, which are underground. Here they are. The colourless, fleshy leaves on the rhizomes are arranged in 4 tight ranks, rather like the overlapping scales on a snake. Here is a drawing that shows the overlapping scales on the rhizome on the left, and on the right is a section through the rhizome. You can see the way each leaf is tightly folded, and running along the seam where the edges join, there is a canal. 10 or so minute tunnels run through this canal into the cavern enclosed by the folded leaf, which is lined by 2 sets of amazing structures, the most abundant of which are mushroom-like in form, each made up of a pair of cells on top of a sort of pillar-like 3rd cell. Here is a drawing of a section through the folded leaf. When these structures are stimulated, protoplasmic filaments are extruded through minute pores in the armour-like cell walls. At the bottom right is one of the mushroom-like structures with its protoplasmic filaments extruded. This happens when tiny animals brush against them. The entrance tunnels are so narrow that only the tiniest of creatures can make their way in: rhizopods and other amoebae, infusoria, rotifers, small mites and the like. Smaller prey are held fast, and larger prey impeded so that they can't escape. In either case, both are slowly digested by the leaf. And unlike the suckers that feed off the roots of the hazel, these leaf cavity traps are at work the whole year round. The Latin scientific name for toothwort is Latreia squamaria. Now, latrios means hidden, and what could be more appropriate given that so much of its life underground is hidden from us? And squamaria means scaly, referring to the scale-like leaves on the rhizomes. As for the English name toothwort, well, the half-ripe capsules bear an uncanny resemblance to human teeth in need of a dentist. So you can imagine that the medieval mind could see this as a clue that this plant was meant as a cure or to give dental relief in a world without dentists or anaesthetics, and that this was the reason why God had created this extraordinary plant in the first place.